Hi, I am Faizatul. I love my garden, but this manual watering is such a tiring chore. I am an engineering student. I should not just be working hard, I should be working smart. Phew, so tired. I think I have to take a nap and think. Wait, I am an engineer. I think I can build the IoT smart plant system. No more guesswork. Problem solved. Yay!
Hi everyone, I am Sim. Following the introduction, I would like to highlight three main benefits of our IoT-based smart plant monitoring system. First and foremost is precision water efficiency. Unlike traditional method that water the plant blindly, our system only activates the pump when the sensor senses the dryness of soil. These can reduce the wastage of water and prevent the plant root to rot due to the overwatering of plant. Secondly, it offers remote accessibility. By using ESP32 with Wi-Fi, we transform gardening into data-driven experience. Busy users like students can monitor real-time temperature and humidity data from anywhere, giving them peace of mind even they are away. Finally, is economical. By using affordable components and preventing plant death, our system saves both water bill and the cost of replacing dead plants. Now, I will pass it to the next group member to explain the construction of system.
I'm Lim Kaiwen. Today I will present about the prototype construction. For this prototype, we use the ESP32 as the central controller due to its high processing speed and built-in Wi-Fi. To monitor the environment, we integrated the DHT sensor and the temperature and soil moisture sensor. For the DHT sensor, we connected to the digital pin of the ESP32 to measure around the ambient temperature and humidity. For the temperature and soil moisture sensor, we connected to the analog pin of ESP32 to measure about the precise water content in the soil. This sensor will provide us the data to determine the plant is need to water or not. When the moisture level drops, the ESP32 will trigger the 5-volt relay module. The 5-volt relay module is connected to the digital pin of the ESP32 and the water pump is connected to the normally open and common pin of the 5-volt relay module. When the current flows through it, it will act as the bridge, allowing the ESP32 to switch the high current battery power to the water pump. To ensure the system is exactly delivering the water, we add the water flow sensor in line tubing. It is connected via PWM capable pin, so the ESP32 will count the pulse and calculate the exactly volume of water delivered, ensuring the water pump doesn't run dry. For the user interface, we connect the OLED displays via I2C protocol. It will provide the real-time reading about the temperature, soil moisture level, and the water flow rate. The entire system is powered by the battery and ESP32, which connect to a power bank. And the pin of the battery will connect to VCC and the ground. So each component normally will contain 3 pins. So one is connected to ESP32, and one is connected to a ground, and one is connected to a VCC. And the place of pin connected to ESP32 is according to our programming. That's all from me. Thank you.
Hi, my name is Yoliana. For this part, I will demonstrate the functionality of our prototype.
The Blink mobile application serves as a user interface for monitoring and controlling the system remotely. On the Blink application dashboard, the soil moisture level is displayed in the real time in the form of value display, allowing users to easily identify whether the soil condition is dry or moist. The temperature and humidity readings collected by the sensor are also displayed directly on the Blink application, providing continuous updates of the surrounding environmental condition. These values are updated automatically as the ESP32 transmits sensor data to the Blink Cloud platform through a Wi-Fi connection.
The operation of this prototype begins with the soil moisture sensor, which is placed directly into the soil. This is the sensor, we place it into the soil. The sensor continuously measures the moisture level and sends real-time data to the ESP32 microcontroller. When the soil is dry, the sensor detects a low moisture value. This data is then processed by the microcontroller and compared with a predefined moisture threshold. If the measured value falls below threshold, the system interprets this condition as insufficient soil moisture. As a result, the microcontroller automatically activates the water pump through the relay module, allowing water to flow to the soil without any manual intervention. While irrigation is in process, the soil moisture sensor continues to monitor soil condition in the real time. Once the soil reaches an adequate moisture level, the sensor detects the change and sends updated data to the microcontroller. The system then automatically deactivates the water pump, stopping the water flow to prevent overwatering. This automated process demonstrates a closed-loop control system where the soil moisture level directly determines the operation of the water pump. Through the functionality, the prototype ensures efficient water usage, consistent plant care, and reduced human effort. This completes the prototype functionality demonstration.
This demonstrates how the Blink application reflects the real-time status of the prototype and supports both monitoring and manual control. Users are able to monitor plant conditions and control irrigation efficiently from anywhere.
When the Blink app is set in auto mode, the water will only flow when the soil moisture sensor detects the moisture level below the threshold value, which is 50%. And it will stop when the moisture level exceeds the threshold value. When the app is set in manual mode, we can water the plants whenever we want, as the system is manually controlled even when the moisture level exceeds the threshold value. The OLED module will display the temperature, humidity, moisture level, threshold level, rate of flow of water, as well as mode of the Blink app, whether it is auto or manual.
My name is Lim Se Chen. Now I want to share the future recommendation for our prototype. We are upgrading this prototype with solar power to create a truly set and forget system by using renewable energy and the ESP32 deep sleep mode. We eliminate manual charging and allow the device to try in remote outdoor location. But we are just monitoring health. We are adding protection by integrating a motion sensor and buzzer. The system acts as a digital scarecrow, instantly detecting and scaring away animals before they can damage the plants. Together, this feature moves us beyond simple irrigation to a fully autonomous, self-defending ecosystem that ensures our plants are both hydrated and secure 24/7 without any human supervision. That is all from me. Thank you for listening.